Okay, so half-life, doubling, tripling. You're going to write this formula down. A equals P R to the T over P. Okay? So some people write AP, some people write AO, some people write all this stuff. I like writing it in a form like this. You'll sometimes see this with other teachers. This is what I like doing. F equals I R to the T over P. Every single formula we're going to use, F and I will be there. So no matter what formula we're using for exponentials, no matter what word problem we get, it will be F equals I. The last part moves and changes a little bit, but the rest will be F equals I. So I always label them F and I. Why do I label them F and I? Because final and initial, exactly. This is the final amount. So that's the amount you have at the end. It's the final amount. This is the initial amount. So if I start off with 1 bacterial cell, there will be 1 in there. If I end up with 1,000 bacteria cells, I'll have 1,000 here. Okay? So final and initial does not change in any of the word problems. The last part does. This is your rate. This formula you use, the T over P deal, when it says half-life, doubling, or tripling in the word problem. It has to have those words. If it has one of those words in the word problem, you use this. So that's the giveaway. If you read half-life, doubling, or tripling, we underline those babies, and we use this formula. So this is your rate. So if it says half-life, R equals 0.5, or a half, right? If it says doubling, what do you think R would equal? 2. If it says tripling, R would equal 3. Everyone's really good with that. It's the T over P that causes mass confusion. Which one technically is closer to the R, the P or the T? If it was written like a fraction, something over something, the P is actually closer, right? If it was written T, straight line P, P is actually closer. The P is the time it takes for that to happen. It's called the period. So it's the time it takes to double, triple, or half. So if it says it doubles every 2 hours, 2 would go there. If it says it triples every 10 minutes, 10 would go there. If it says it has a half-life of 10 years, then a 10 would go there. Okay? So it's the time it takes to half, or double, or triple. The top T, the top one is time as well. It's the time it takes to get to that final amount. It's the total time. It's the time it takes to reach the final amount. So if it says, in 10 years, I have 1,000 bacteria, I put 10 there. Okay? If it says, how long does it take me to reach 10,000 bacteria, then that's the one I would be looking for. So it's time to reach final amount. That's an F for final. Final amount. It's hard to write on this one. Time to reach final amount. Okay? All of these are word problems, which means they're extremely wordy. So we need to read through them and figure out what the heck it's asking us and what it's giving us. So we're going to underline stuff that's of importance. Actually, I'm going to highlight it. I can find a highlighter. In pink. No, blue. Okay. A lab tech placed a bacterial cell. So many people miss that because it doesn't say 1 bacterial cell. It says a bacterial cell. So if it doesn't have a number there, they're like, nah, it's just words, and I just keep moving on. Or you don't even read it. Read every word. A lab tech or read them correctly, placed a bacterial cell into a vial at 5 a.m. 5 a.m. probably important. So that, it undoes it. That's weird. So at 5 a.m. they placed a bacterial cell. Why is 5 a.m. important? Because that's the time they started, right? So you still get your time in hours and stuff like that, but if they ask you what time it took till it reached blah, 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 you could tell the time. Now, the other thing is this T and P have to be in the same units. So if time is in hours, then the P has to be in hours, okay? One's in minutes, the other one has to be in minutes. That's just an aside. The cells divide in such a way that the number of cells doubles. Here's that key word, doubles. That means I need to use this formula because there's the word doubles in it, right? Doubles every 4 minutes. What is that? Doubles every 4 minutes. Is that P or T? P. Because P is the time it takes to double, triple, or half-life. So you know if you're given P, if it follows after the word doubles or triples or half-life. If there's not a number that follows after doubles, triples, or half-life, I would bet my life that they're making you find that number. Okay? So if it doesn't say doubles every 4 minutes, it'll say it in the question. It'll say, how long does it take to double? Well, then it doesn't give you P. It's asking you to find P. Or how long does it take for it to half? Then it's asking for that P value. Okay? So doubling means our R is what? What's our R? 2. Every 4 minutes means our P is 4. Now I know my T is going to also be in minutes, or it has to be, right? Because they have to be in the same units. A bacterial cell is what? What is I? Yeah. I is 1. 5 a.m. is a good number. 5 a.m. we're really only going to use if when we find time, we could add the time to the 5 a.m. and tell you what time it happened, like 7 a.m. or 8, right? Okay, so that's all the information before the question happens. Now let's go to the question. How long does it take for the cells to divide to produce 4,096 cells? And how long? So, how long does it take for the cells to divide to produce 4,096? So, what did they give us? I know. So F equals 4,096. What are they asking us to find? Time total, so T. And the answer is going to be in minutes, correct? If they asked you at what time does it take to reach 4,096 cells, you'd get your time in minutes, and you'd add that to 5 a.m., and you could give me the actual time it happened, right? They didn't ask us that. So we have all of our stuff. We know F equals 4,096. I equals 1. R equals 2. P equals 4. T we're trying to find. Now, in order to solve these, you can only be missing one letter, right? We're missing the little t, which is good. If we were missing more than one, you have to go back and think I must be missing something because I can only be missing one thing because you have to only can solve for one, right? So let's fill in what we do know. So the formula is F equals I R to the T over P. F is 4,096. I is 1. R is 2. T I don't know. So you can leave it as a T. Whoop, that's really ugly looking T. T over 4. What's great about these? We can solve them in our calculator. First step always. This I value, no matter what word problem we are doing, we are going to divide that over. Often it will get you to a smaller amount. We're dividing by 1, so it's not going to do too much to us. But we will always divide that I over before we put it into our calculator. So I'm going to divide by 1. We don't divide the I over if that's what we're finding, because there's a 1. So technically we've done nothing, but that's okay. 4,096 equals 2 to the t divided by 4. Now, I always put t divided by 4 in brackets. The only reason why I do that is because if you have a calculator where the exponent doesn't actually pop up, you know how it's like some of the calculators, the exponent pops up? If the exponent pops up, you don't have to put it in brackets. If your exponent, however, does not pop up, if your exponent does not pop up, you have to put it in brackets if it's a fraction, which it is. Okay? So we're going to go y1, y2. So punch that into your y1 and your y2. So in my y1, I'm going to have 4,096. So that means that there is going to be a line, horizontal line drawn at 4,096 on the y. So your little 10, 10, 10, 10 window is not going to help you because it's going to be like maxing out down here and you're going to have 4,096 way floating up here. Okay? And then we're going to have 2 to the exponent. If your exponent pops up, like I said, you don't have to put in brackets, but mine doesn't, so I have to go x divided by 4. Now, I'm going to go to my window, and I'm going to make my y max be at least bigger than 4,096, because if not, I'm not seeing that horizontal window. So I'm going to say 5,000. Okay, and I'm going to press graph and just see what happens. Okay. Now, what you want to do is you want to find out where they cross. So some people just go second, trace, 5, enter, enter, enter. You might say, but I can't see anywhere that it's crossing. So if it says that, it might just be that your x needs to be bigger, right? Because you're not actually seeing it. So go to your window, quit. Go to your window and make your x max be 100. Sure. If you can't see where they cross, you can't calculate it. Sometimes, though, you guys, it's so tight to the y-axis that you actually can't see it, but it exists. So what I always do is no matter what, before I even swap my window, I just go second trace 5, enter, 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 and see if it gives me an answer. If it does, yay. If it doesn't, I have to adjust my window. But I always just check first to see if maybe it'll give me the answer, because maybe I can't see where it's crossing, but it's actually there. You know what I mean? Sometimes it does that. So now I can see it. So I go second trace 5, enter, enter, enter. What if you are stuck and you cannot get the window whatsoever? What's your last resort? Zoom fit. Zoom fit that baby, and maybe it'll give you where it crosses, or at least maybe it'll give you somewhat where you can see something and you can like adjust from there. Okay? So 48 is our answer. 48 what? Minutes. So it takes 48 minutes to go from one bacterial cell to 4,096. Does that make sense? Let's think about it. With these questions, it should make sense. It doubles every 4 minutes. So in 4 minutes, I go from 1 to 2, right? In 8 minutes, I go from 2 to 4. In 12 minutes, I go from 4 to 8. Doesn't seem like it's going up quickly, though, right? But it will. Remember, exponential graphs start like at a slow slope, and then all of a sudden, boom, they're flying upwards when you're growing exponentially. So then it goes from 8 to 16, 16 to 32, 32 to 64, 64 to 128, and now it's growing fast, right? And it's going to grow quick. So in 48 minutes, that does seem reasonable. If you say like 17 days, think did something wrong. Like it's growing a lot faster than that. Okay? So let's look at this one. Write this one down. There's a little catch on this one. So just write it down for now. So what is the half-life? Keyword there, half-life, right? If we get the word half-life, we know we need to use that formula. If it says double, if it says triple, we know we need to use that formula. Half-life means R is what, guys? 0.5, or you can use a half. Plutonium-232. Cross out that 232. It's a wonderful thing. It's an isotope of plutonium, of which I have no idea it is, and I don't really care. But you guys try and put 232 somewhere in the question. Okay? Don't. It's just plutonium-232. It's a type of plutonium. Cross that 232 out. Please do not try and put it somewhere in the question. Okay? Now, let's listen. What is the half-life of plutonium-232 if in 204 minutes Is it giving us the half-life? It's asking us, what is the half-life? What's it asking us to find? Half-life is R. R equals 0.5. Which letter is it asking us to find? What is the half-life of plutonium-232? P. It's asking us to find P. Normally, if it gave us P, it would be like the half-life of plutonium-232 is 20 minutes. Or plutonium-232 halves every 20 minutes, right? But it's not giving us that. It's saying, what is the half-life? Well, R is 0.5. The only thing I have left to solve for is P, right? What is the half-life of plutonium-232? If in 204 minutes, a lot of people want to put that as P. P is how long it takes to half. If in 204 minutes a sample decayed to 164 of its original mass. So what is 204 minutes? T, because that's the final time, right? If in 204 minutes it decays 1/64 of the original mass, right? So that's giving us that final time. Now, what people freak out about is they're like, I need to know what F and I are. Obviously, I don't know P. Now I'm stuck. You didn't give me enough information and you suck. Or you'll call me over and you'll be like, there's not enough information for this question. Okay? If it tells you it decayed to 164 or 1/64 of its original mass, it doesn't matter what the original mass is. Make one. Make whatever the original mass be, whatever you want it to be, and your final mass will be a 1/64 of it. Of always means multiply. So if you're doing 1/64 of a mass, you'll do that mass times 1/64 and you'll get the answer. So in this case, you get to pick whatever original mass you want it to be, times it by 1/64 and you'll get the final mass. So this is why it's a problem. It lends you opening to be able to pick whatever original mass you want. If it lets me pick whatever original mass I want, I make the original mass be 1 or 100. Okay? Those are my options that I pick. Don't make it be like 27.5. You are making your life suck. Don't do that. Okay? We don't want that happening. So if it lets me pick my original mass, I'm going to make my original mass, my initial, be 1. Then my final is 1/64 of that number. So I go 1 times 1/64. This is why I pick 1. What's 1 times anything? Itself. If you pick 100 and you times it by 1/64, that's fine. You can do that as well. That's an okay option too, because it gets rid of the fraction. But I always pick 1 just because 1 times itself is itself. So 1/64. You could have picked your initial to be 100, times this out, then when you divide your I over, you're still going to get a final of 1/64. It'll always work out, okay? Because you're finding 1/64 of the original mass, okay? So let's fill in what we do know. We know final is 1/64 equals my initial, which is 1. And I'm going to prove to you that doesn't matter what I pick in just a second. R is 0.5, T is 204, over P we don't know. Now I divide that initial over every single time. When I divide by 1, it just happens to be 1. It's not always 1. Just keep that in mind. 1/64 equals 0.5, 204 over P. Now, I want to prove to you that if I picked a different initial, it would still work. Okay? Don't write this down. Just pay attention. So once you have this written, put your pencils down. Do not write anymore. Do not press go. Do not click pass go. Do not click press go. Who presses go? I don't know. Anyways, so don't write it here. Don't write anything. We're just paying attention. Say I picked my initial to be 100 instead. Okay? Then I pick my final to be 1/64 of that. So times that by 1/64. What's 100 times 1/64? 1.56. Is that rounded? 5625. So it's going to be 25/16, let's say. Or 1.5625. 5625. We're not writing, we're just paying attention. We're not writing, we're just paying attention so that we catch what I'm saying. So I picked 100 this time instead of 1. Okay? So my final is going to be 1.5625. My initial is going to be 100. Right? This is still 2. This is still 204 divided by P, right? 2. It's a half. I don't know why I wrote 2. I'm going to write 0.5, so it's the same as level. Okay? What did I tell you the first thing to do is divide by your initial. This just happens your initial this time isn't 1, right? It's 100. So I'm going to divide that over. So I'm going to go 1.5625. And I'm going to divide it by 100. And I'm going to go math, enter, enter. And what do I get? 1 over 64 equals 0.5 to the 204 divided by P. What was my equation? 1 over 64, 0.5 to 204 over P. Did it make a difference that I picked an initial of 1 or initial of 100? No. It just matters that you take your final and divide it and times it by whatever the heck your initial is. When you divide your initial over, you're going to get the exact same one. Okay, so it doesn't matter. You could pick 36.25 as your initial. That would be ridiculous. Okay, you're going to have horrendous decimals. So there are better numbers to pick. I always pick 1 if I have the choice, because then I'm just dividing by 1 or timesing by 1, which does nothing. Okay. All right. This one is different than the last one because the last one was 4,096 as my Y1, right? This one's 1 out of 1 divided by 64. It's a really tiny little decimal. So your Y equals line is going to be like below 1. Okay. So if you leave your window as what it is now, you're going to have a graph that looks like this. Okay. You're going to have a graph that gets you this exponential, and then your horizontal line is going to be so small compared to the 4,096, it's going to look like it's on the x-axis, and you're going to think there's no other horizontal line, and you're going to think you can't calculate where they intersect. Okay? So even if you left it the same window, you'd be able to find it, but you might not notice that there actually is a horizontal line there. So that's why I said sometimes just go second trace 5, enter, enter, enter before you touch that window, and maybe it'll find it for you, and you won't even know it's there. It's so great. That's what your calculator's for. So we're going to go Y1. And we're going to go Y2. And when it's a half-life question, often the 10, 10, 10, 10 window works for you because it's this little line over here is so tiny. And if you can't find it, it's often that your X max just needs to be made bigger. So some people are like doctoring their Y's and their X's, and they're making their X min really small. Often the only thing you need to change is your X max because you can't find it because your X max isn't big enough. Okay? So before you go doctoring everything, change your X max. So I'm going to go zoom 6 and just set it back. And then I'm going to go clear these. If ever your calculator is like thinking for 700 years and you're pressing clear and every button you possibly can to get it to stop, and you just have to sit there and you're like, oh, this is taking forever. If you just go second on, it stops it from doing it. So if like you got some crazy, like look, this is like trying to calculate it. So say I cleared these out. So say I put 2 to the X, and then I put 1,000 or something, and I press graph, and it's calculating. I'm like, no, I didn't mean to do that. If you go second on, it stops it. Wonderful little thing. Great. Figured it out once when I was mashing my calculator trying to get it to stop. It just stopped. I was like, this is the greatest thing ever. So if you want it to stop mashing your calculator, that is the only way it stops it that I figured out. Okay? Second on. It just stops it. And it doesn't turn it off, which is great. So this is a fraction. Fractions always have to be in what? Brackets. So we're going to go bracket 1 divided by 64. If you happen to not put this particular fraction in brackets, it would still work out because all you have is one little single fraction by itself. But I always just put fractions in brackets every single time just so I don't make any oopsies. Then I'm going to go 0.5 to, and I can put in brackets if I really wanted to. Doesn't matter. To the power of bracket 204 divided by x. Now I told you, if your exponent pops up, it doesn't have to be in brackets, but you can put it in brackets anyways. It's not going to hurt it if you're a bracket person like I am. I'm going to press graph. Okay, so I go second trace 5, enter, enter, enter. And there's no second curve. What is going on? Okay, maybe I should go like this. Second insert. Just want to check, maybe that's doing it, but it might not be. So what did I tell you to do? Sometimes there actually is a line on here, just so you know. If you don't trust me, go like this. Make this thicker. It's on there. You just don't see it because it's so tiny. It's so close to the x-axis that that 1/64th line is so tiny. It's right there, though. Okay, so I'm going to go to my window, and I'm going to make my x max substantially larger. So I'm going to make it be 50. I'm going to go second, trace, 5, enter, enter, enter. Does it look like you have any idea how you got that? No, don't fight it. Just try it. That's all I have to say. Sometimes it's like, yeah, there's no way that that's happening. Remember, this is a decreasing exponential graph, right? So it's running decreasingly along here because it's a 0.5. So often when it's a half-life one, the 10-10 window works. You just have to make your x max substantially larger. So I guess technically the 10-10 window doesn't work, but you just set it there and then just keep making your x max bigger. Often the issue is that your x max isn't large enough. Like ours wasn't. It takes 34, right? 34 what? Is it minutes again? Minutes. What does this mean? 34 minutes to what? 34 minutes to what? To half. Every 34 minutes, the total, whatever I have, is halving. It's halving. It's halving. It's halving. It's halving. So it's getting smaller, right? So often it's radioactive material that they do half-lives on a lot of the time. Okay. I'm going to get you to try a couple questions, and then we're going to start the class off tomorrow with a group of 4 people, and you have to try and come up with the total answer out of 4 different word problems that are all these. Okay? So it's 3 questions. Textbook, page 363, numbers 10 to 12.